All right. So we'll start by talking, we're going to be talking about moles. We'll talk about moles and how they relate to chemical formulas. But so to kind of illustrate the point, I'm going to go through what's going to be a little bit of a, maybe a ridiculously overblown sort of thought experiment. So let's just start with thinking about water. So just think about one molecule of water. And what is in that one molecule of water? Well, there's 2 hydrogen atoms and 1 oxygen atom. Now, let's think about if you had 2 water molecules. So, of course, you would say there's 4 hydrogen atoms and 2 oxygen atoms. What if I had 10 water molecules? I would have 20 hydrogen atoms and 10 oxygen atoms. What if I had 1,000 water molecules? I would have 2,000 hydrogen atoms and 1,000 oxygen atoms. So you start to see that I could do this with any old number, really. I could pick any number out of the blue. So I'm just going to pick a number totally at random and pick 6.022 times 10 to the 23rd water molecules. Obviously, this isn't a number at random. I'm doing this to sort of prove a point. But therefore, we'll have 6.022 times 10 to the 23rd oxygen atoms and 12.04 times 10 to the 23rd hydrogen atoms. So you have twice as many hydrogen atoms as oxygen atoms. Another way, a quicker and easier way to say this is if I have 1 mole of water molecules, I have 2 moles of hydrogen and 1 mole of oxygen. So I went through this whole thing because a lot of times students get troubled by the idea that I'm saying there's 2 moles in 1 mole, forgetting that moles is just a quick way of talking about numbers of things. So it depends what we're talking about moles of. So in 1 mole of water molecules, there's 2 moles of hydrogen and 1 mole of oxygen. The larger lesson here is that any ratio, right, 2 to 1, that holds when we're talking about individual atoms and molecules also holds when talking about moles. So let's think about magnesium hydroxide. There's a ratio I can pull out of here. For every mole of magnesium hydroxide, there's 2 moles of oxygen. So now I have a ratio. I have a ratio of 1 mole to 2 moles. So 1 mole of magnesium hydroxide, the whole thing, to 2 moles of oxygen, and likewise 2 moles of oxygen to 1 mole of magnesium hydroxide. So this is the third of the little tools in our toolbox. Imagine moles of A, right? And I can go between moles of A to particles of A. And then I can go from moles to grams of A. And I can go from moles of A to moles of B. Now, it's important to understand in this drawing, the relationship between A and B is one of them is a whole compound and the other is an element within the compound. So let's say that B is an element within A. And we can do the same sorts of calculations with B as we can with A, grams of B. So there it is. So we have this sort of little diagram. So if you get stuck, if you can remember this diagram and draw it, you can sort of put the pieces together. Now, here between particles and moles is Avogadro's number, 6.022 times 10 to the 23rd. 6.022 times 10 to the 23rd. The relationship between grams and moles is the molar mass of A, and here is the molar mass of B. And then here is the ratio from formulas that we've seen. So let's actually put this into practice a little bit. So let's start here. Let's talk about a whole molecule. So I'm going to do these 2 different problems. I'm just going to launch into them because you may not have seen these in practice. So ethanol molecules. So let's talk about how many ethanol molecules are in 21.6 grams of ethanol, C2H6O. Well, what we need first is we need to know the relationship between grams of ethanol and moles of ethanol. So what we need is the molar mass of ethanol. And getting out my calculator here. All right, so what I need to do is I need to find the molar mass. So 12.01 times 2 plus 6 times 1.06. Okay, so the molar mass is 46.08. So there it is. So those my units are canceled. But now I want to know how many molecules. Well, we go moles of C2H6O to 6.022 times 10 to the 23rd C2H6O molecules. So now 21.6 divided by 46.08 6.022 times 10 to the 23rd. So then we go 2.82 times 10 to the 23rd molecules. C2H6O molecules. And then the next problem, how many grams of oxygen are contained in 27.03 grams of this compound. So first things first, I need to go from grams of C6H5NO3, grams C6H5NO3, moles C6H5NO3, 1, and we'll calculate the molar mass real quick. Okay, and then moles C6H5NO3 to moles of oxygen, right? So we're going to relate this. So there should be 3 moles of oxygen for every 1 mole of C6H5NO3. And I'm going to have to carry this down over here because I can't quite finish it over on the side here. So on the bottom I need moles of oxygen, and then I want grams of oxygen. So 16 grams of oxygen to 1 mole of oxygen. Now a lot of times people ask me, well, do I need to have 3 moles of oxygen down here? And the answer is no, because you never try to match the numbers up here. And sometimes people say, well, do I need to have the mass of 3 oxygens in O3? Well, no, you're taking care of the 3 over here, right? That's what this ratio does, is it multiplies by 3, so you just need to know the mass of 1 mole of oxygen atoms. So now we calculate this out. And I get 9.450 grams of oxygen. There we go.